This is a video lesson for Module 5, Lesson 10. The Lesson 10 learning target is I can use the area model and division to show the equivalence of two fractions. So we're going to be building on our learning from Lesson 9 and looking at how we can use division to find equivalent fractions using non-unit fractions in this case. So let's go ahead and jump in to the first problem. So I'm going to be using division to find an equivalent fraction that is equal to the fraction represented in this area model. So first, let's quickly determine what the fraction, what is that fraction being represented in this area model. And we see that there are 10 equal sections shaded in out of 12 total. So it looks like we're dealing with 10/12ths here. So just like in Lesson 9, I'm looking to see if I can group my shaded and non-shaded regions into the same, into equal-sized groups. So if I look at my non-shaded, I have these two that are right here, and it looks like I can group all of these into twos. So since I can group them into twos, in order to find an equivalent fraction using division, I would say I can do 10 divided by 2 over 12 divided by 2, and that is equal to 5/6. So I found an equivalent fraction for 10/12ths by grouping my area model here into sections of 2 and then dividing by 2 to get 5/6. So pretty similar process to our work with Lesson 9, but just a little bit trickier with the non-unit fraction. So let's keep on moving and show how we can use this area model and division to find multiple equivalent fractions for a fraction being represented in an area model. So you can see hopefully that both of these area models represent the fraction 8/12ths. And we know that because there are 8 sections that are shaded in red and 12 sections total in each of the area models. So using the similar process we've been using with these area models, I'm looking to see if I can create equal-sized groups out of the shaded and non-shaded region. So for this first area model, I'm looking and I can actually see that just like in the first problem, I can make groups of 2. So I'm going to go ahead and do that now. So circling my groups of 2. Now, since I was able to make groups of 2 out of this area model, I can find an equivalent fraction by dividing the numerator and the denominator by 2. So I'm going to go ahead and do that now. And remember, when we're finding equivalent fractions, we always want to make sure we're dividing or multiplying the numerator and the denominator by the same number. So in this case, it's 2. So 8 divided by 2 is 4. So we can actually see that there's 1, 2, 3, 4 sections that are now shaded. And 12 divided by 2 is 6 because there are 6 sections or groups total. So we were able to find one equivalent fraction by making groups of 2, but if I'm looking at this area model, I can also see that I can make groups of 4, just like this. And so since I can make groups of 4, I can also take this fraction 8/12ths and divide the numerator and the denominator by 4. And when I do that, I get 2/3, because 8 divided by 4 is 2 and 12 divided by 4 is 3. And you can actually see that in our area model here. Let's see if I can highlight this in blue, because we have this section here is shaded. And this section here is shaded, so that's the 2 right here. And then this section here is unshaded, making the third part. And so there's 3 groups now. So that shows the 2/3. So you can see that using division, we can find multiple equivalent fractions depending on if the numbers are divisible by multiple numbers. So the last problem we're going to look at here, we're going to move away from the area model a little bit. And we're just going to look at how we can simplify that same fraction we just looked at, but to make sure that it is written in the largest possible units. So we're going to be making sure that we have 8/12ths written in the largest possible units. And what I mean by largest possible units is I want the denominator to be the smallest number possible, because I know that 1/2, or like halves, are going to be larger than something like twelfths, which are smaller. So to simplify 8/12, we just saw that we can divide 8/12 by multiple numbers. So we could divide 8/12 by 2. And get 4/6. Now, if we are able to divide that equivalent fraction, an equivalent fraction that we found, by another number, then we know that we're not at the largest possible units yet. So we could actually divide 4/6 by 2 as well. And equals 2/3. Now when I look at 2/3, I see that I can't divide the numerator and the denominator by the same number and end up with an equal number. So since I can't divide the numerator and denominator by the same number, I know that I have my largest units. So this is my thirds, is the biggest units that I have, that I can find an equivalent fraction for. Another way to think about finding the largest units possible is to find what is called the largest common factor. Largest common factor. We're looking for the largest common factor of both the numerator and the denominator. So if you'll recall from previous lessons, a factor is one of the parts of a multiplication problem. So it's a number that you can multiply by another number to get an answer. So like 4 times 2 equals 8. So these would be factors right here, 4 and 2. So to find the largest common factor, we have to think of all the factors of both the numerator and the denominator. So in my head, I'm kind of thinking, what are the factors of 8 and 12? And so I'm thinking really quick. Well, 8, I know I have 1, 2, 4, and 8. And then for 12, I'm like, I have 1, 2, 3, 4, 6, and 12. And so to find the largest common factor, I look and see, well, these are common. 1 is common. 2 is common. But I want to find the highest number. And so in this case, that's 4. So in order to make sure that I'm finding an equivalent fraction that has the largest possible units, I would divide the numerator and the denominator by 4, because that is our largest common factor. So you see I get the same answer as I did up here when I divided twice. So that should cover it for Lesson 10, and you should be able to solve any of the questions in the Lesson 10 problem set. But as always, you can come back and rewatch any parts of the video if you do get stuck on any of those problems.